Today's lesson is going to cover evaluating piecewise functions. This should be page 42 in your notebook. The goal today will be to evaluate and calculate a piecewise function when provided the input value. So our piecewise functions are things that you know how to do. It's just putting a new name to it. So key terms today. A piecewise function is composed of several pieces of functions that cover a specific part of the domain. So here would be like the equation of a piecewise function, where this function has three pieces to it. It's got one piece right here, two pieces, three pieces. And these would be like the pieces or the smaller functions. And then these are the x values or the domain that they cover. So when the input value is less than 5, this is the equation I'm going to use. When the input value is greater than or equal to 20 and less than 100, this is the equation that I'm going to use. So these are the domains that they cover. If you want to know what a piecewise function looks like on a graph, you can see here we've got multiple piecewise functions, and you can see that the function is made up of lines with different slopes that have different equations. So that's what a piecewise function would look like on a graph. Here we've got like a quadratic, we've got a constant linear function, we've got another linear function, all make up the piecewise function here. So let's get into a couple problems. So here we have our first example, and it gives us this function equation. This function also has three pieces to it. It's asking us to find the output for when the input is 6, 12, and 21. So if I want to know what the output for 6 is, I'm going to plug 6 in, and I've got to figure out, okay, which equation am I going to use? So I'm going to use the domain first. So my first step is to find the equation using domain. So 6 falls in between 0 and 6, and because this is an equal to, x can equal 6 here, I'm going to use this top equation. Below, this also has a 6, but this is saying when x is greater than 6, well, 6 isn't greater than 6, it's equal to, so the top equation is the one that I'm going to use. So I'm going to put in 6 for x, and then I'm just going to follow order of operations. So I'm going to square this, and then I'm going to multiply it by 2. 6 squared is 36, and 36 doubled is 72. Just to verify using the calculator, 2 times when 6 is squared, the calculator's enlarged for some reason, 72. Okay. Now 12. So 12 fits in between 6 and 21. So I'm using this equation. And I'm just going to put this in the calculator. Minus 4. Equals 140. So our first part of these is to find the equation using the domain, which is the inequality part. And then our second part would be to simplify expression. Last one, 21, fits in between these two because 21 is equal to 21. So I'm going to use this equation. Negative 3 plus 2 times 21 cubed. And 21 is the base here. I'm not cubing the 2. So negative 3 plus 2 times 21. 21's being cubed. Gives me 18,519. So that's how I'm going to do this first part. And now this second part is asking us to calculate. So this second part, which is the calculating part, all this is really saying is the output of f of 12, or the output for the input 12, which we know the output for the input 12 is 140, minus the output for the input 6. Well, the output for the input 6 was 72. So we're just doing 140 minus 72. I'm going to go ahead and use the calculator for this. 140 minus 72, 68. And that would be my answer. So our third step would, for calculating, would be to subtract the outputs. Example number 2. We're only doing 2 examples today. So we've got f of 0.05. 0.05 fits in between 0 and 5, so I'm going to put in my input for x, top equation, squared, and I'm going to use the calculator for this. And I get negative, oops, I put that in wrong. Double 2 zeros, so equals negative 0.0025 would be my answer. 5.15. 5.15 is greater than 5 but less than 12. So I'm going to put it into the top equation. So 2 plus 3 times 5.15 squared equals 81.567. 56.75. And the last one, 12.6 fits into between 12 and 20, and it's negative 4 minus 12.6. Which is negative 16.6. Now I'm going to calculate, so the output of the input 5.15 would be 81.5675 minus, and the output for the input here was a negative 0.0025. So here I have a double negative, so I'm actually going to add them. So 81.5675 plus 0.00025 equals 81.57. Click on the homework.